This is section 6.2, larger systems of linear equations. So it's going to be similar to 6.1. We are going to use the calculator. If you go through view the example, they're going to show you how to use back substitution. I'm going to show you how to use a matrix on your calculator. So we're going to set up a matrix. It's going to be similar. You're going to have an X column, a Y, a Z, a W, and then a constant. So the last three equations don't have an X, so we're just going to put zeros in. The second column are our y's. So we have 3, -4, and the last two don't have y's. So we're going to put zeros. For the z column, we don't have one at the bottom. And then for the w's, 1, -7, 5, 1. And then let's put our constants in. So that's the matrix we're going to set up, and we're going to let the calculator solve it for us. So let's flip over there. So we had a second matrix, and we're going to edit. I'm just going to use A again. Instead of a 2 by 3, this one is a 4 by 5. Okay. And if you get the wrong dimensions, you can just arrow back and get the right dimensions. So let's put all those numbers in. Minus instead of negative. The last, oops, that was wrong. Go back. 1. All right, so when I put the 3 in, again, I need to hit enter so it saves it. I would recommend that you write the matrix out on your paper first and then put it in. I'm going to go back and double check real quick. Just checking my numbers, make sure my signs are correct before we solve it. Okay, so I double checked everything. Second mode gets me out of there. So we're going to go over to math. We're still going to do RREF, the row reduced echelon form. Again, I just like to keep using A. And you can close the parenthesis, you don't have to. Okay, and if they need these as fractions, all right, so this is X, Y, Z, and W. So we're just going to leave it here. We're not going to do anything. We're not going to go to the matrix. So we're going to hit math. And if you go over to fraction, it's already on numerator, denominator. You're going to hit enter. And that's the wrong one. Give me a second. Hit math. Here we go. We're already on fraction. All right, so this first one, this number 1, will convert your answers to fractions. So you're going to hit enter. It's going to take the answer, convert it to fractions. So I have to hit enter again. So it gives you the fractional answers. So let's write that out. I'm going to do that down here. 9 and 3. So that's the solution to that system. This one, they just want you to write the matrix out, which is what we've been doing. So X's, Y's, and Z's line up. And they may have a line in here. Put the constants on the other side. So again, there are a few questions they just want you to write out. They call it the augmented matrix, where you just have the numbers that are in front of the letters there as far as setup, what we've been doing. All right, and this one's taking us in the opposite direction. They want you to write out the system of equations, so they want it with the actual letters in there. So since there are 3, it's just going to be x, y, z. If there was 4, it would be x, y, z, w. Don't ask me why. And then the column on the right are the constants. It's on the right side. Think of this as your equal sign. So let's write this down here. I second right up here. 7x plus 5y plus 1z is equal to 2. All right, so we have a 0x. We just don't write that. So it's 5y plus 6z equals 27. My z's, I put a line through them so they're not mistaken for 2's. I have a negative x plus 3y plus 2z. That's going to be equal to 21. All right, so we have this system here. It's already solved. It's called the identity matrix. When you have a diagonal of ones, that means it's been solved and all the other zeros, and the solution is on the right. So they want you to find the solutions, but we need to double check that last row. Okay, there's a 1 that would be x, y, and w. X, Y, Z, and W, I'm sorry. It's 1W is equal to 2. So just make sure the last row doesn't look weird. We may have a couple of examples of those, and I'll cover those. All right. So x is 2/5. Y is negative 2. Z is 3. And W is 2. So that system has one solution. All right. So this one, we just have ones and zeros on the left. But if you look at this last row, it's a little different. I don't have a 1. Ideally, we'd have a 1 here. Since we don't, that means it's one of the special solutions. So 0x, I'm looking at the last row, here's what I'm dealing with. 0y plus 0z is equal to 2. So no matter what x, y, and z are, when we multiply them by 0, we get 0. And this is not a true statement. So this is an example of no solution. Just look at that bottom row. So whatever notes you need to make, this is a good place to put them for when you go to take the test. Examples of no solution. The one on the right is infinitely many solutions. I always spell infinitely wrong, so I just abbreviate. And that's because the whole bottom row are zeros. It's a true statement because 0x plus 0y plus 0z, that's just 0. So that statement is true. So you have infinitely many solutions. Now I'm going to show you how to write the answers. All right. So we have 4 variables, x, y, z, and w. I don't know why they do it like that, but we'll just go with it. All right, so w is just going to be equal to w. Okay. And then this one, this is z. Z is equal to -9. All right, so then this one here, we have 0x plus 1y plus 0z plus 4w equals -3. We need to know what y is equal to, so we're going to move the 4w to the left. So y is equal to -4w minus 3. All right, on the top row, we have X. We have 0y, 0z plus 3w equals 11. And I need to find out what X is, so I'm going to move the w to the left. So it's negative 3w plus 11. So when you put it in, you'll select infinitely many solutions. That's X. That's Y. That's Z. W is W. And that's how you would put the solution into MyMathLab. And this is the end of section 6.2.